Hello and welcome to this section. In this section we will develop a high-level understanding about what we mean if we talk about models in the context of machine learning. Let's take a look at a real-life problem that works pretty similar. Assume you want to bake an apple pie exactly the same way your grandma did this when you were a child. You need some ingredients and technical equipment. These are the requirements. You need apples, sugar, some eggs and a baking oven. But what you need on top is the logic to actually bake the perfect pie. You need to know the exact amount of apples, sugar and the other ingredients. You also need to know how to combine them and the baking time so that you get the desired result. Imagine you have no idea how to do this and you can't ask anybody for the recipe. So the only option you have is trial and error. You will bake many pies with the right amount of eggs or apples or baking time, and each time you record how close the result to an actual apple pie is. This way you find what the best recipe is. Based on the knowledge you gain, you can perform some interpolations. For example, you recognize that 2 eggs are too few and 4 eggs are too many. You just might conclude that 3 eggs must work best. So you create a recipe for the best apple pie. Now you will see how this works for a machine learning model. It is actually pretty similar. Your task is to develop a dog-cat classifier, which will provide a label for an image that is showing either a dog or a cat. You have independent variables. In this example, there are different images of cats and dogs. These are passed then to a model together with an actual label for each image. And the model is then able to learn what makes a dog and a cat special and how to separate both. After the model is trained, you can pass it an image of a cat or a dog that the model has never seen before, and it will provide an answer. Basically a label whether a cat or a dog is on the image. So there are many similarities to our apple pie analogy. A machine learning model needs plenty of data to learn a model. So for developing a machine learning model, you take existing data, including your target variable, and feed this into an algorithm that creates a model. If you want to make use of your model, you take new data that don't have any information on the target variable and let the model predict the target. Here you can see a more detailed version. You start by ingesting your data. The data usually needs to be cleansed and or transferred for further usage. And usually you split your data. In a later section you will learn why. So let's just assume you need to split the data into training, validation and holdout or testing data. And the training data is used to train the model. The validation data is then applied for evaluating this model. At this point, you might modify some parameters and run the loop again to see if the performance increased. The holdout data is applied only once for a final test if the model really works. Let's take a look at an example. You typically have a task of predicting one or more target variables. There are many names for the same thing. So don't get confused if you read dependent variable, for example. This means the same. You also have independent variables, also called predictors. These are used to create a model based on an underlying relationship between independent and dependent variables. So both independent and dependent variables are passed to an algorithm that creates a model. The model learns the relationship between the data. After learning, the model can be applied to new data and predict the target variable. That is, in short term, the basic idea of all supervised learning techniques. In our example, you can see the column species is our target variable. It has many labels for the data, like setosa, versicolor, and so on. You also can see the columns, sepal length, sepal width, petal length, petal width, which are our independent variables. Independent variables are usually referred to as X variables. Here we call them x1 to x4. Target variables are referred to as Y variables. Here we only have one target variable, y. The model takes all observations, which means all lines in this dataset, into account and finds the relationship of all these columns x1 to x4 to the target variable. If you now specify a new measurement of x1 to x4, the model can predict to which class the observation belongs. So that's it for this lecture. Thank you very much and see you in the next one.